Welcome to Unit 2, Logical Reasoning. This is Section 1, Set Theory, Chapter 1. At the conclusion of this chapter, you will be able to develop logical reasoning by analyzing puzzles and games that involve numerical and logical reasoning using problem-solving strategies, as well as solve problems that involve the application of set theory. Many elements in our world lend themselves to being parts of a group, such as a sports team, art clubs, flocks of birds, etc. Some members belong to more than one group, as they have a variety of characteristics common to each one. This section will allow for categorizing items into groups called sets. The reason behind this form of organization will be applied to other situations, such as games and puzzles. Here is the checklist of requirements to complete this section. Part 1. Types of sets and set notation. Each part, of course, will have accompanying notes and practice. Part 2. Relationships between sets. Part 3, intersection and union of sets. 4 is applications of set theory. And Part 5 is games and puzzles. You'll have to do a demonstration and analysis in this part rather than the notes and practice. It's the best part of this whole course. All right, set theory review. There's a formative assessment, as well as a curriculum review, a set theory quiz, and a logical reasoning section exam as your final summative assessment. The first thing I've done is added a vocabulary page. So what you need to do is determine a definition for each of the terms listed, okay, as well as provide an example, okay. So an idea that you could use here is set would be a group sharing common characteristics. An example of a set would be the set of real numbers. Okay? Awesome. So, what you need to do then is pause the video and make sure that if you haven't already completed this page, that you do so now. Return to the video once that is done. Okay, Unit 2, Section 1, Set Theory. This is Part 1, Types of Sets and Set Notation. There are many different types of sets, as well as ways to distinguish and group them. In this section, those types and ways to identify them will be discussed. You may wish to have your set theory vocabulary list handy that you just completed, and in addition to your Math 30-2 formula sheet available in the resource section of the website. If you have a textbook, turn to page 6 in the Principles of Mathematics 12, and we're going to do the following investigation. If you don't have a textbook, you have everything you need listed here, so either one is fine. All right, we got Jasmine. She's studying the provinces and territories of Canada. She decided to organize them using sets. All right, so list the elements of the universal set of Canadian provinces and territories and call it C. I did an abbreviated form of this, so using the abbreviations for each province and territory. So we're going to list it as C, and C will equal. Now remember, when we write things in terms of sets, we use the curly brackets. Okay, so across the top we have Yukon Territories, we have the Northwest Territories, we have Nunavut, BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, New Brunswick, Nova Scotia, Newfoundland and Labrador, and Prince Edward Island. Okay, so that's all of them. One subset of C is the set of Western provinces and territories. We're going to call that W. Write W in set notation. So again, we'll start with W equals, curly bracket. The Western provinces and territories include Yukon Territory, Northwest Territory, Nunavut, BC, Alberta, Saskatchewan, and Manitoba. All right. The Venn diagram below represents the universal set C. The circle in the Venn diagram represents the subset W. The complement of W is the set W prime. That's a W with a little tick mark there. Okay, we call that tick mark A prime. All right, describe what W prime contains. Well, if W is the set of all the western provinces and territories, then W prime would be not the set of western provinces and territories. Or, in other words, the eastern provinces and territories. Okay? Write W prime in set notation. So W prime equals, curly bracket, everybody else. So we have Ontario, we have Quebec, we have New Brunswick, we have Nova Scotia, we have Newfoundland, Labrador, and Prince Edward Island. Okay, explain what W prime represents in the Venn diagram. So if W is in the circle, W prime would be everything outside the circle, but still within the rectangle labeled C. So anything inside the rectangle but outside the circle. All right, that was fun so far. Next page. Jasmine wrote the set of eastern provinces as follows. Is E equal to W prime? Explain. Well, the order is different, but does it have the same elements as W prime does on the previous page? Newfoundland, Labrador, Prince Edward Island, Nova Scotia, New Brunswick, Quebec, and Ontario. Looks like it to me. So, is E equal to W prime? The answer is yes. Okay, E does equal W prime. Because although the elements are in different orders, I think I got too many F's in there. Oh, I can't spell. Here we go. There we go. They are the same elements. Okay, good. Part E. List T, the set of territories in Canada. Is T a subset of C? Is it a subset of W or W prime? Explain using your Venn diagram. Okay, so T is Northwest Territories, Yukon Territories, and Nunavut. Is T a subset of C? So, is T a smaller group, basically, in the group of all Canadian provinces and territories? And, of course, the answer is yes. T is a subset of C. Okay. And also, what other one does it belong to? All of those things were found in W, and also of W. Okay. Because all elements in T are also in C and W. Okay? They are not in W prime, so not, a subset of W prime. All right, part F. Explain why you can represent the set of Canadian provinces south of Mexico by the empty set. Well, how many Canadian provinces would you find south of Mexico? That's right, none. So therefore, how do we represent that? Well, because none of the Canadian provinces are found south of Mexico, then there would be an empty, also known as the null set, to represent it. Okay. Part G. Consider the sets C, W, W prime, and T. List a pair of disjoint sets. Is there more than one pair of disjoint sets? Remember that disjoint sets don't contain elements that are the same. So we know that all of the elements in W and the elements in W prime are disjoint because W's elements are not found in W prime. Okay? We know that T is also not a subset of W prime, so therefore they would be disjoint. Okay? So, again, disjoints are sets that do not contain similar elements. Okay? Complete your Venn diagram by listing the elements of each subset in the appropriate circle. Okay, I might need to make that just a little bit bigger so I can fit them all in for you. Okay, so in W, we have a subset of Nunavut, Northwest Territories, and Yukon Territories. And we also have Alberta, BC, Saskatchewan, and Manitoba. Okay, we'll draw another circle in here to represent W prime, and that's Ontario, Quebec, Nova Scotia, Newfoundland, Labrador, New Brunswick, and Prince Edward Island. Okay, great. Scroll that back in. So hopefully, there we go. All right, hopefully you can read all that. Next page. There's a number of symbols used in this section that we're going to use regularly. If you forget what they are on your formula sheet, okay? So, if we're given A with the little tick mark, A prime, that's the complement of A. If you have O with a line through it, or if you just have empty curly brackets, that of course is the null or empty set. An upside down U is known for the intersection of the two sets, and a right side up U we use for union of two sets. A sideways U, or it looks kind of like a C, we use that for subset of another set. Proper notation is written the way how domain and range were in previous units on functions. So when we did domain, notice again the curly brackets. X belongs to reals, and the range 1, 2, 3, 4, again in the curly brackets. So the curly brackets indicate that it is in set notation. Okay? In this example, the domain is an infinite set. Real numbers is infinite in size, whereas the range is a finite set. There's only a set amount of numbers inside the set. Whew, said that a lot. All right. Also notice that the notation n element refers to the number of elements within the set. For example, nd is infinite, while nr is 4. Again, referring to the number in the domain and the number in the range. Please notice that in this section, you'll be required to know the meanings of words such as sum, difference, product, quotient, multiple, factor, prime, root, square, consecutive, odd, even, natural numbers, wholes, integers, rationals, irrationals, and real numbers. If you are unaware of what these terms mean, please research them before continuing. Example 1. 2 6-sided dice were rolled. Illustrate the following sets in one Venn diagram. Rolls that produce a sum less than 6, rows that produce a sum greater than 6. Record the number of elements in each set. Okay, so let's draw a rectangle to represent our total set. We're going to call that S for sums. Now, we have two things. Roll a number that is less than 6. So I'm going to have a circle there, and I'm going to label it L for less than. And I'm going to have another circle over here, and I'm going to label that G for greater than. Are my two sets disjoint? Can you have a sum that is less than 6 and a sum that's greater than 6? Okay, of course the answer is no, so therefore my two sets are disjoint. Okay, smallest thing, if you roll 2 die, each die of the smallest number is 1. So 1 plus 1 would be 2, would be our smallest sum. We could have a sum of 3 by adding 2 and 1, a sum of 4 by adding 2 and 2, or 1 and 3, and a sum of 5 by adding 2 and 3. If we have a sum that's greater than 6, we would have 7, we could have 8, we could have 9, we could have 10, we could have 11, and of course each die has maximum of 6, so 6 plus 6 is 12. That's our largest sum. Is there a number here we're missing between 2 and 12? Right, we went from 5 to 7, because of course it doesn't have anything included that is the sum of 6, which we can do by adding 3 and 3. So because it's not less than or greater than, it is still a sum when you add the two die, so we're just going to put it outside of the two circles. Okay, part B says record the number of elements in each set. So the number of elements in S, our entire set, is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The number in L is 1, 2, 3, 4. And the number in G is 1, 2, 3, 4, 5, and 6. All right, great. Now it's your turn to practice. Make sure that you show your teacher upon completion of the formative assessment found on page 14 in your textbook. You'll also be able to find that on the website. So that's 1, 2, 3, 6, 9, and 11. Good luck.